Okay, so we're going to continue to look at some of these word problems right now. So take a minute, see me pause this one and read through it, and then we'll look at it together. So Zach and Victor drive a semi for Hy-Vee, and one day Zach, by the way, Zach is with a K, so we'll go ahead and correct that, averaged 50 miles per hour, and Victor averaged 56 miles per hour, but Zach drove 2 more hours than Victor. If together they covered 683 miles, then how many hours did Zach drive? Okay, so with this, one of the things to identify is this total. So once again, we have a total, and this time it's distance. So there is a formula for distance. Distance is equal to rate times time. So if my total distance is 683 miles, my total distance is the distance Zach drove. So we'll say Zach's distance plus Victor's distance. We'll say Vic's distance. So we know distance is rate times time. Zach drove at 50. So let's make that rate times time. And then rate times, I'm going to use a lowercase t. Usually that's what we would do for time. So if Zach drove 50 miles per hour, that's his rate. And we know Victor drove 56 miles per hour. That would be his rate. And then we got to figure out how long they drove. Well, we don't know too much, but we do know Zach drove 2 more hours than Victor. So if x is Victor's time, then Zach's time is x plus 2. And that's probably the most difficult part of writing this equation. So make sure you pause that and take a minute to think of that. We'll say x is Vic's time. And so now we have an equation that we can solve. You can distribute the 50. And then we add those together, we get 106x is equal to 583. When we combine like terms, and then 583 divided by 106, I need a calculator for that, but it's 5.5. And that was x, and this is why you write this down so you have kind of a reference to it. That was Vic's time. So Vic drove 5.5 hours, which we don't actually want to know. We just want to know how many hours Zach drove, but he drove 2 more hours. So Zach drove 7.5 hours. Okay, let's look at another driving one. This one's a little bit different, just with the way it's set up. But Violet drives to the beach in 45 minutes. By averaging 10 miles per hour less, her roommate Veronica drives the same way to the beach in 54 minutes. So in this case, their distances are equal. So distance is equal to distance, because they're both driving to the beach. So let's make this Violet over here and make this Veronica. Now, you don't have to worry too much about the minutes and miles per hour here. It's kind of a weird exception for some, but because they're equal to each other, and the time will cancel each other out, basically is what happens. And so distance is rate times time. And we want to do that on both sides. I'll just use r and t over here. So Veronica's rate, or Violet's rate, we'll get that in a minute, but it's 45 minutes time. And then Veronica's rate, we'll get that in a minute. The time we know is 54 minutes. So by averaging 10 miles per hour less than her roommate Veronica drives the same way to the beach in 54 minutes. This is roommate. Let's put a comma there. There we go. Veronica drives the same way to the beach in 54 minutes. What's Veronica's average speed? So you got to decide if you want to do addition or subtraction here. So we could say, let's make X be Veronica's speed, which we want. And so if X is Veronica's speed, then Violet drove faster, X plus 10. And if you check your equation, that makes sense because of the fact that Violet takes more time. Keep getting the names confused. It's tough. But now we have our equation. So we have distance, or rate times time is equal to rate times time, or distance is equal to distance because they drove the same path. Okay, so this is 45x plus 450 when you distribute is equal to 54x. So 450 is equal to 9x, and then x would be equal to 50. So we said x was Veronica's speed, which is what we want, and it'd be miles per hour. So Veronica drove 50 miles per hour. That's what we want. Okay, we'll switch it up a little bit again with this word problem and talk about some percentage. Still, the key here is always look at total. So the total is $915.60. And it includes 5% of the sales tax. So your amount that you pay for something when you buy something with sales tax is the price of the item plus the sales tax, and that's the total you pay. We don't know the price of the item. That's what we'll say is X. And the sales tax is 5%. So to find sales tax, they take the price and multiply it by the percentage. So we do 0.05 times X, and that's the amount that is charged additional. So X is the price. If we want to know the sales tax, so keep that in mind. And so we can combine these to get 915.60 and then divide to find X. And I need a calculator there. So it's 872 is the price. That's X. So if I take that times 0.05, then I can find the actual sales tax, which was $43.60. And you could subtract too. You could subtract the total minus this price, and that's what's left for sales tax also. Okay, let's get another percentage problem. Once again, start with the total. So this is after a 30% price reduction. The price of a new computer is $849.99. Okay, so that was after the price. Well, how do you find a reduction? Well, you start with the price and you subtract the refund. And that will give you your, we'll say, final price. So this is original price minus the refund is the final price. So we don't know what the original price is. So let's put that. But we knew they took 30% off. So to find 30%, you do 0.30 times X. You can also think of this as if it's 30% off, then it's really only 70% of the original. And then you can divide, let's see, 849.99 divided by 0.7. That's not, sorry about that. That's 0.70x for 70%. And you get the original price of $1,214.27. Now, one thing, whenever you're doing percentages, you can make sure the answer makes sense. So just say, okay, well, first, is it bigger? Then yes, and then you can even work backwards. You could plug it back in, or you could try to take 30% off of that and see if you get it. But make sure it seems, it's bigger. It's not like twice as big. That'd be too big. And so this does make sense. Okay, we're going to look at this mixture problem. And this is kind of a staple of college algebra. But we're going to do this with this, what I call the Easter egg method. But it's really just doing the rate times amount. So we're going to put our amount, which is our percentages, up top. Our rate, which is our percentage up top, and the amount on bottom. Now, it doesn't matter which one's on top and which one's on bottom, because what we're going to use is what's in the middle. So we want to know how many liters of 10% hydrochloric acid. Look down here. So that's 10%. And I don't know the amount, so I just put X there. It should be mixed with 12 liters of 20% hydrochloric acid. So we'll put 20% here. And I know the amount, 12, to obtain a 14% hydrochloric acid solution. So that's the amount, or the percentage is 14, and the amount we got to think about a little bit. So if I have X and then I add 12 to it, then you get X plus 12. And maybe like if you knew the total and you didn't know these, then you would subtract, right? So you could add or subtract for that third spot on bottom. And then to get your equation, you just multiply top and bottom, and that gives you 0.10x, and then 0.20 times 12, and 0.14 times x plus 12. And this middle stripe called the Easter egg, because it kind of looks like 3 Easter eggs, gives you an equation that you can solve. We'll just rewrite this down here. And I would pause the video and try to solve this. And just make sure you distribute carefully. So we get 0.1 x plus, that'd be 2.4 is equal to 14x plus 168. If I subtract, let's subtract this over. Get 13.9. And then subtract that over. Get 157. Oh wait, no. What was I doing? 165.6. Forgot my x, and then divide. Oh, I forgot my decimal up here. Something didn't look right. All right, so bear with me here. Let's fix this. So I'm going to start over down here. So if I subtract 0.14 over to the other side, I get negative excuse me, 0.04. And then if I subtract 2.4 from both sides, I get negative 0.72. And so x is equal to 18. Okay, and that is what we wanted. We wanted the amount of hydrochloric acid there. So it'd be 18 liters. Okay, so one thing and to keep in mind with this, hang on, let me just double check this. So one thing is like mistakes will happen, right? So I made a mistake. I forgot a decimal point when I rewrote that. But I got down here, I was like, well, why do I have a negative x? I must have done something wrong. So always with word problems, make sure your answer makes sense. It wouldn't make sense to have a negative amount here unless I was taking something away. Maybe that would make sense, but that's not the case. So work carefully, check your work. And with this, these problems are difficult, so make sure you practice. And if you have questions, let me know. We will be doing more of these in the future, I am sure.